outside. Okay.
Okay.
Which means that whatever the inside function is, you do that. All right. Now, typically they give you two functions here. They're giving you the same ones. It's kind of a little wonky because it's kind of like, I don't know if you've ever seen those nesting dolls, you know, where there's one doll inside the other, but there's a function inside a function, which is a little bit awkward, but that's what you're going to have when it comes to, you know, this course. And maybe you got to go in and take calculus. I can't remember. So when they're asking you to find f of x, what they're saying is, and I'm going to write f of x twice here. They're saying to take this right here and put it in for x. 3
Okay.
times 3x cubed like that. So wherever you see an x, you replace it with 3x cubed. Okay, so if you had two functions, like typically it's like f and g, the g goes in for x. This ends up being, because you got a cube first, 3 cubed is 27, x cubed is x to the 9th because you're multiplying, and then you multiply that 3 in and you get 81 x to the 9th. If you haven't figured it out by now, there's a million calculators out there that'll help you do it, or like you said, maybe you're figuring it out by hand. So this is the part B answer. I didn't snip the part A stuff, but essentially
it was just a definition. Yeah.
Okay, so this is
Okay.
where you can either share your screen again. I can
All
give
right.
you another problem like this, which I don't recommend since you have problems for us to work on. You can also, you've got a Windows machine. If you do a search for your snipping tool, you can just create snips and drop them into the chat as well. Whatever is going to be easiest for you here to for us to work on.
All right. Well, let me go on to let's try module 2 since that's where I'm at. And we'll go to skills practice.
Sounds good.
And I haven't looked at this yet, but we can look at it together, I guess.
Sure. Yeah, so you're moving into a completely new part of the course here. This is a more of a calculator problem. So let me go ahead and share my screen. I'll offer some guidance
Okay.
here as well
Okay.
with this. You know, I know you're a return student, which means you did this at some point. You may not remember, but you did it. It's just actually find the tangent of 64.3. So one of the things I always show students is there's some really good online calculators. I'm not talking about the ones where they do the work for you. I'm talking about like our legitimate, like, wow, this is a really cool calculator. So I'm gonna drop this in the chat for you and see, and I'll also share my screen so you can take a look at it. So we need to find the tangent of 64.3 degrees. So I'm going to new share that here with you. You should see with this Desmos Scientific. One of the reasons I like it is you can type it in exactly the way you see it. You don't have to sort of mess around with things like that. Now, you might remember this from geometry, trigonometry. You have to specify whether in your degree, which you are in here, that's that little bubble on your problem, or radian. So this is the answer. It says to round off the result according to the provided table, which I didn't snip in. So, you know, I don't know what the answer, I don't know what it exactly said there, but you're either rounding to 1, 2, or 3 decimal places. If you want to reshare your screen, I'd be happy to
Okay.
to look at that with you, but definitely recommend that. Okay, so since we're going to the 10th place, that's 3 significant figures. So if you saw me, I wrote down 2.0778, you would go to 2.08
Okay.
for your answer there, just to get you an idea of what to expect. All right, so you know those are nice. I don't know, will you get those on a test? I mean, maybe if they're Pearson, if it's all in
Yeah.
Pearson.
So once you put that into that calculator, it automatically gives you the answer without hitting enter. It
Yeah,
gives you the answer
which
while
is
you're
nice.
typing it.
Yes,
Okay.
exactly. So it's kind of like what we expect in modern tools. We don't expect to, like, you know, if we used to, maybe we had a calculator in a
Right.
previous course, you know, in person course, it can be a little bit cumbersome to use. Okay, so I'm going to share my screen again, and if you're okay with the back and forth, you know, I'm fine with it as well.
Yeah,
It's a
that's
little
fine.
slower than just you queuing up a bunch of questions for us to work on, but here we go. This one's different. They're not giving you the angle. They're not giving you the angle. They're giving you the answer to, and you got, I guess the Embry-Riddle emphasizes this is 1, 2, 3, 4, 4 significant digits. So that
Mhm.
means our answer is going to go to 2 decimal places like that. Okay. So how do we solve this? If you recall from, an earlier part of the course, or, maybe previous time, you undo it with the cosine inverse. So if you go back to that calculator, and I guess I might as well do that here. Go back to that calculator, and so you can see that. So one of the nice things here is you can hit enter and get a new line. You can keep your old calculations, but if you go to func for function, you will find some of the other ones that you need in this course, and that's the 0.7946, like that. And you can see you get an answer there on the right. You don't even have to enter. You enter, you get a new line. So I'm going to snip that back over into the other uh, space here, and
You want me to go back or where do
now
you
let
want
me
me?
let me I'm going to share my screen
Okay.
here. Just give me a moment here.
Okay.
So again, like we need our answer to 2 decimal places. So this would be 37.38 rounded.
Okay. It was asking, I'm sorry, at the top, was it asking 2 decimal places? It was asking?
Well, I'm just interpreting this table. So this table,
Okay.
in the previous problem, we were given our answer to, we were given the angle to 1 decimal place. So this is the angle. So if the angle is given to 1 decimal place, our answer has to have 3 significant digits. Now we're going backwards. We're saying our answer has 4 significant digits. That's on the right. That's
Mhm.
sort of our
Oh,
answer or
okay.
our output. And then you have to say, okay, well, that means my answer has to have 2 decimal
Two
places.
decimal places. Oh, that makes
And
sense.
and that
Okay.
becomes more important, when you get to the test, when you only get 1 submission.
Right. Okay. Okay. So 37.38. Okay.
Yep. So whenever you're ready, if you want to share your screen again,
Yep.
we'll keep working through some problems here. Get as much as we can done. We'll go to about 5:35 for the try it out here, and then we'll
All right. So it looks like we have to do the Pythagorean theorem for this to get the other side. Is that correct?
that is partially correct. You're going to use some of the Pythagorean theorem here, and they're again giving you that guidance with the significant figures, but less important the more we do. So I'm going to grab my snip here. I'm going to share my screen, and we'll kind of talk about what to do. Again, I would definitely encourage you to take notes as we go, but and even do the calculations as we go. That's very important here. So you can see on the right here, there's a triangle. Angle C is 90. Angle A is 22.6. Probably good to put that in. C is 0.0711. And then we're trying to find A, B, and then big angle B. Okay. So to find big angle B, remember that all 3 angles have to add up to 180. So that includes this 90, which means the other 2 angles have to add up to 90. So B is 90 minus 22.6, which is 77.4 degrees. So that's your first answer there. Is that okay?
Yes. That's
All
pretty
right.
simple. All
Yeah.
right.
Now the next 2 parts, you mentioned Pythagorean theorem. You can only use Pythagorean theorem if you have if you have 2 of the 3 sides, and we don't. We only have 1 side. So we have to actually use right angle trigonometry. This is your sine, your cosine, and your tangent. And not to just throw a bunch at you, but I am going to drop a reference sheet in the chat that does seem relevant here. I'll grab a link to that. There it is. You're in kind of the trigonometry part of this course. So these reference sheets are good to print out and have by your side here. So we want to find, let's just say we want to find angle A, or sorry, side A. So side A is opposite the 22.6. And you're given the hypotenuse. So if you recall, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So the sine of 22.6 degrees equals A over 0.0711. Does that make sense? Or have you not seen that in a while?
That's been a while.
Okay. So if you had some time, it'd be good to go in before our lesson and obviously like look at some things that,
Yeah,
because I can give you all the explanation, but you ultimately need questions to be done.
right.
Get through this. So to solve for A, you multiply both sides by the 0.0711, 0.0711 sine 22.6. And that's where you go to your calculator. If you don't mind doing that for me, could you go to your calculator and do that calculation? Um, we'll compare results here in a moment. And we need to go to 4 decimal places. So whenever you're ready, if you want to give me your answer to 4 decimal places, we can do that.
0.0407.
So I got 0.0273.
Let me see.
So that takes care of A, 0.0273. Now 2 choices to do B, like you mentioned, Pythagorean theorem, which should be fine, or you can use trigonometric stuff again. I'd probably use the trig stuff again because I think that's what they're emphasizing. So to find B up here is the adjacent, and we're going to use the hypotenuse. So cosine 22.6 equals adjacent over hypotenuse 0.0711. And then you solve this just the way we did the last one. You multiply both sides by the 0.0711. And sometimes I don't show the steps here. So just always say, hey Matthew, could you show the steps, or could you clarify that again? This time is for you. I don't mean to suggest that we need to like rocket through some of this. So B is equal to 0.0711 cosine 22.6. And so if you're if you're clever, you can just change sine to cosine, and then you don't have to make any further adjustments
So
here.
you
That's
put that into the calculator just like that though?
exactly, yeah, exactly. That's the whole
Okay.
point of this calculator is you use it more like we use tools in our real life. We don't think about syntax and formatting and all that.
I got 0.0583.
We've got a different number again. Make sure you're using cosine.
I know what I'm doing wrong. Let me see. I'm gonna share my screen real quick and see what I'm typing in wrong.
So you have rad selected, RAD. It needs to be in degree.
Oh
So
my gosh,
that
that's what it
that
is.
that yeah, it's usually something that simple. So. All right,
Okay.
good. Gonna go ahead and get those entered. We'll pause here for our try it out lesson. I don't know if you want to enter those real quick before we close out. Yeah, so big B was 77.4.
7.4.
You got it.
Little A was
0.0273.
0.0273 and E was 0. 0, 6, 5, 7. Was it
I got
7?
6. I got 6.
Oh,
You,
6.
sometimes you gotta be careful with even one decimal place there. So,
Yeah.
all right, so there's a
27.
problem there. Maybe I didn't round right. Let me double check here.
Okay.
Point zero, what did you have for second? 0.0273? 0273. Oh, because they're only going, we only need 3 significant digits because they're only going out to one decimal place. So 0.027, remove that 3. And 0.066.
6.
Yeah, let's try that. Wow.
Oh,
I'm at,
it's the first one. You call it something else.
oh yeah, it's 67.4. Sorry, that was an addition error on my part. But that, yeah, go ahead and change that to 67.4 and that should
What about the other two? Are those other two good?
they should be 3 significant figures because of that. So let's try it. You can always redo it, no big deal. So it's I actually did want the 4.
Oh,
So
this was the one before.
yeah. Okay, so
Okay.
anyway, we're rushing here a little bit at the end, which I
Okay.
don't like, but that's okay. So let me
No.
quickly go ahead and
Let's
stop the
see.
recording here, give you a little more information that you're asking for. Um,
Oops.